Okay, so this part is to transit you from your E-math chord job to A-math chord job. So there is some overlapping idea. So whatever you have learned from E-math chord job is still applicable. Just that for A-math chord job, we'll be adding new stuff. Okay, so the length formula that you learn in E-math is still applicable. So whether is it in A-math chord job or A-math circles. So A-math circles also fall under chord job. Okay, the gradient formula is still applicable. Maybe the midpoint formula is something new. So this one is applicable only for A-math, not E-math. So I'm going to show you the idea on midpoint. So there's a few cases that you've got to be using midpoint. So later on, you'll be using midpoint in perpendicular bisector, and you'll be using midpoint in some geometrical shape, like rectangle, parallelogram, rhombus. Okay, so I'm going to use a numerical example to show you. Okay, so if you look at the formula, right, it is like x1 plus x2 divided by 2, y1 plus y2 divided by 2. That means essentially you are sharing the x coordinate and you are sharing the y coordinate. So the midpoint that you have found will cut into exactly half. So you will use this for perpendicular bisector. So okay, so you can label it as x1, y1, x2, y2, whichever one that you want, you just label it. So if I want the midpoint, I'm going to share it out and I'm going to divide by 2. Share out the x and share out the y. So this will be important parts in equation of perpendicular bisector. So later on you will see it. Okay, then the x-intercept that you learn in E-math chord job will still be applicable. So x-intercept, y-intercept. So when you are finding x-intercept, okay, it's always putting y equal to 0, substituting y equal to 0 into the equation. Finding y-intercept is always putting x equal to 0. So this one has been done quite a lot of time in your E-math chord job. It's still applicable. Okay, and we learn collinearity in E-math chord job. So when something is collinear, 2 or 3 points are collinear. They just mean same gradient. So we also have same gradient in A-math chord job that falls under the part on parallel line. So in parallel line, we will be having same gradient. So you got to note the idea of parallel line. The question will state something about parallel line. So you need to be able to extract out the gradient. So how do you extract out the gradient? You got to make y the subject so that you can extract the gradient. So whatever you learn in E-math on making y the subject to get the gradient is still applicable in your A-math chord job. Okay, another property that we will always have will be the substitution of a coordinate. So a lot of people will have a mind block or they wouldn't think of it. So if a coordinate is on an equation, you can simply substitute the x and substitute the y into an equation. So let's say I can give you an equation like this. Okay, let's just take a simple one. And then I got a point like K4. So you can just substitute inside. So if you substitute inside, you will get something like 4 equal to 2k plus 1. So whichever coordinates, as long as the coordinate is like living on that line, you just substitute the x coordinate and the y coordinate. And one of the most important feature will be intersection. So that was one of the most important feature. So if you couldn't recognize intersection, you get stuck in a lot of cases. So there are two scenarios that you will need to take notes. The first scenario will be you actually get two straight lines. So you got two straight lines. So when do you do simultaneous? When you would like to find the intersection. So you will solve and you get your x and y. This x and y will be the intersection. So I'm going to find the x and y by doing a simultaneous equation. So this one is going to be so common. Okay, another case will be you might get a curve. You might get a curve, or you might get a circle later on. Okay, this will happen in the circle part. So this is the one where you got two intersections. So you got to use the curve as one equation, the straight line as one equation. So for the under the circle part, the circle can be one equation, and then the straight line is another equation. So in case number 2, when you do the simultaneous, it will most probably lead you to quadratic. So you got two possible answers. That's why you will have two intersection points. Okay. So that will be one of the critical one. Another one will be finding equation. So finding equation is always being asked. So you got to look under whether you get a case 1 or a case 2. So generally, if you need to find an equation, you will need a gradient and a point. So this is the gradient, and then this is the point. So once you get the gradient, you put in the coordinate to get the point. So will they give you the gradient, right? If for A math job question, their gradient will not be so direct. So the gradient can come from parallel line, which you got to make y the subject. Or the gradient might come from perpendicular line, which I'm going to show you the gradient of a perpendicular line. Okay, case 2, you only get 2 points. So when you only get 2 points, right, you still need the same idea. You will still need the gradient. And you choose one of the point. So maybe I will choose this one. So whenever you want to find equation, it will always be mx plus c, and you will always need a gradient and a point. So once you get a gradient and a point, so that's how you carry on. I think I substituted wrongly. So no matter what, in E math, that's what you do to find equation. In A math, it's the same thing. You just have to look around in the whole question to come up with a gradient and a point. So it doesn't change your idea. You will still need the same ingredient for equation of a line. So let's talk about gradient and lines and perpendicular lines, all that. So this will be the brand new concept. So in E-math, we always do parallel line. So in E-math, we'll do parallel line. So parallel line, they will have same gradient. Okay, so for example, they got same gradient and maybe this equation is something like this. So what will be the gradient? So you make y the subject. You must make y the subject, then you can tell the gradient. So this will be gradient minus half. This one will also be gradient minus half. So they will share the same gradient, but you must have the automatic sense to make y the subject. So in a case of perpendicular line, so perpendicular line will look like this. Okay, let me try to make it more perpendicular. So there will be a 90-degree to show that the two lines are perpendicular. So line 1 and line 2 are perpendicular. So it means that the gradient will multiply and get a -1. So this is called the formula for perpendicular gradient. So this is called the formula for perpendicular gradient. So maybe I use the same example like just now, like this one. So let's say I give you a numerical example. So maybe I change the equation. Okay, so these two are perpendicular. Okay, so let's say I know this equation. So this equation is something like 2y minus 2y plus x. Okay, maybe we'll make it the same equation like just now. Okay, so the same equation as just now. And I'm trying to find this gradient. So what you can do is same, you manipulate already. You will know that this is the gradient. Then what about the other one? So maybe we label the other one as M. Okay, we label this as M1 and then maybe we label this as M2. So how are you going to find M1? You put it into the formula. M1 times M2 equal to -1. I know my M2 is minus half. So you manipulate that equation will help you to calculate. So that's how you get the gradient 2. So this equation, this gradient will be a 2. So numerically, that's how we use this formula. Okay, then we talk about the equation of a perpendicular bisector. So there are two features of a perpendicular bisector. Okay, it must cut at midpoint. That's why we use the midpoint formula. And it must cut at 90°. That's why we will use the formula for perpendicular gradient. So how does a perpendicular bisector looks like? So in Sec 1 or Sec 2, Sec 1 most probably, you construct the perpendicular bisector. So if you still remember in Sec 1, you use your compass and protractor. You do something like this, remember? So that one is your perpendicular bisector. So this is called the perpendicular bisector of AB. And right now, in set 1, you constructed it. Now in set 3, your job is to get the equation. So getting the equation, you will still need the gradient. You will still need the point. So the gradient will come from perpendicular gradient. The point will come from the midpoint, which I'm going to show you in the next example.